Welcome back everyone to this lecture on deep convolutional GANs. Deep convolutional GANs are actually not a huge leap from what we just did. They basically just add in convolutional layers to attempt to build GANs better suited for image data. It makes sense that if we use convolutional layers for image classification, we should probably also use them inside of our discriminator to classify fake versus real images, and we should also take advantages of their unique 2D capabilities to actually generate images. So what we're going to do in this lecture is we're just going to take a look at the DCGAN notebook that we have for you, and we're going to see at what the changes are inside of the notebook. We're not going to actually code this all out because really there's just a few changes as far as building out the models and then compiling the models. Everything else pretty much remains the same. It's just the actual layers you're putting in there. So it's just a couple of more imports and then setting up the layers, and these are things you can always experiment with. Let's go ahead and load up that notebook and walk you through it. Okay, here I am at the notebook. You'll notice that everything at the top is pretty much exactly the same. We load up the data. However, the one thing that we do need to change is reshaping and rescaling the images. Our generator at the very end uses a hyperbolic tangent activation function. And a hyperbolic tangent, if you actually plot this out, the limits of a hyperbolic tangent go from -1 to 1. And our images either go from 0 to 255, or if you scale them down, they go from 0 to 1. We actually want to make sure that our training data is going to have the same range off of this hyperbolic tangent activation in that last layer. So what we need to do is we need to reshape it to be between -1 to 1. So the way we do that is we just take all our training data, we divide it by 255, so then everything's between 0 and 1, and then we multiply that data after reshaping it times 2, so now you have everything between 0 and 2, and then if you subtract 1, well then the lowest values from 0 go to -1, and the highest values at 2 go to 1. And then your minimum becomes -1, and your maximum becomes 1. And if you just take a look at what the hyperbolic tangent looks like, you'll see what I'm talking about there. Okay. Then we continue just as we did before. We went ahead and filtered out only zeros. If you want, for these more complex convolutional network-based GANs, you can go ahead and just use all the data. Just keep in mind, training time should take longer. And then we're going to import a couple more layers here in order to try to get the best performance possible. We still have dense and reshape, but what we're also doing is we're importing leaky rectified linear unit. It's an activation function that tends to work a little better than just a rectified linear unit in this case of deep convolutional GANs. And then we're also going to be performing batch normalization, as well as getting these two convolutional 2D layers and also this transpose layer. So we have these extra layers, and essentially we just build out the generator and discriminator using those extra layers. So if we take a look at the generator, let me zoom in one more here. We can see it starts off sequential. We also have this dense layer. Here we have 7 by 7 times 128. You can kind of choose how many neurons you want there by editing 128. And then we reshape this to be 7 by 7 by 128. And for that batch, we then perform batch normalization. Keep in mind, you have a lot of leeway here over how many neurons you want in each layer, or how many kernels there should be in the next convolutional layer. So what we do here is we have a convolutional 2D transpose layer, and then we decide to have 64 kernels. Kernel size is 5, strides is 2. Note that padding we keep the same. A lot of things you can experiment with here. And then we add in another layer of batch normalization right before our second convolutional 2D layer here. And at the very end, we just have one output for that image. Okay. Then we have discriminator, which is a sequential model. And notice it's kind of like a mirrored image a bit of the generator. So we start off with a convolutional layer of 64. We add a little bit of dropout here, 50% dropout to try to prevent overfitting, hopefully making the discriminator stronger between real images versus fake images. And then we add in another convolutional 2D layer, expanding the number of kernels or image kernels there. And then we also add in a dropout layer of 0.5. At the end, we flatten all this out to a single dense neuron, essentially saying, is it a real image? Is it a fake image? And notice the activation is sigmoid because of that. Okay, then we combine these two into the sequential generator and discriminator GAN, and then we compile the discriminator using loss binary cross entropy because it's essentially real or fake, it's binary, and then we set discriminator.trainable equal to false before we compile the full GAN. And the full GAN also takes binary cross entropy with optimizer atom. And from that, it continues the same way we left off last time. We can see the two layers, we can set up the training batches. Notice training batches set up just the same as before. One thing to note here is we're going to train this for a lot more epochs because these networks are a lot more complex. It's probably going to take a lot more epochs to actually get good results. And because of that, this is really where you need to be using GPU to have a reasonable amount of time for training. Training loop is pretty much exactly the same. So we see the exact same training loop as we did before. And if you scroll down, I trained it for 20 epochs here. You can see my results. Recall that our previous models suffered mode collapse, and the actual images themselves weren't super great, but using deep convolutional GANs with only zeros, we can see here we get much better results. And what's really nice here is we also get variety in our results. So we don't just get the same zero for all of these. Okay, so really interesting stuff and a lot of stuff you can play around with here. I would highly encourage you to play around with all the different hyperparameters that are available to you within this network. Just make sure to use a GPU so you're not waiting forever for all your new designs. Okay, thanks, and we'll see you at the next lecture.